Hi, this is Mrs. LaBarbara. This is AP Physics Chapter 4, Newton's Laws, Video 3. Today's topic is Newton's second law. The objectives for today is to understand the relationship among the net force on an object, the object's mass, and its acceleration. Be able to apply Newton's second law. When the net force is not zero, take a look. We have three scenarios. The first one, A, is a part moving with constant velocity. When the force equals to zero, its acceleration equals to zero. So when the net force equals to zero, the object is in equilibrium. The acceleration is zero and its velocity is constant. When a constant net force acting in the direction of a motion will cause a constant acceleration in the same direction as the net force. As you can see, B and C, a net force is applied and acceleration is produced in the same direction as the force. When an unbalanced force acting on the object, it will cause the mass to accelerate. The acceleration will be in the same direction as the net force. So B is the case when the force is applied in the same direction as motion, your velocity will increase. When a force is applied opposite direction of motion, the velocity will decrease. So in both cases, acceleration is in the same direction as the force. Now let's see the relationship between acceleration and force. Let's look at the pictures. A constant net force causes a constant acceleration. So force causes acceleration. If you double the force, acceleration also doubles. If you halve the force, acceleration also halves. For any given body, the magnitude of acceleration is directly proportional to the magnitude of net force acting on the body. So the relationship between acceleration and net force are directly related. The acceleration and net force are always in the same direction. So for example, even as a part moving a circle with constant speed, at all points, the acceleration A and the net force F points in the same direction always. So they are always in the same direction. Let's take a look at the relationship between mass and force. So the ratio of magnitude of force to the magnitude of acceleration is constant, regardless of the magnitude of net force. This ratio we call that the inertial mass, or simply the mass. So as you can see, mass is not affected by the force. Mass is a quantitative measure of inertia. The greater its mass, the more a body resists being accelerated. The SI unit for mass is the kilograms. Next one, let's take a look at the relationship between mass and acceleration. So first, let's take a look at a graph, A and B. A known force, sum of F, causes an object with mass m1 to have acceleration a1. If we apply the same force, sum of F, to a second object, and acceleration, and noting the acceleration will allow us to measure the mass. So if we can figure out, we know mass m1 is, we know what F is, we can measure a1. We can measure, if we know m1, we can measure a1, therefore we can determine F. We can use the same force to apply to another object, we measure a2. This is one way to figure out m2. But usually on Earth, we use the weight to measure the mass. But deep in space, we can use F equals to ma to measure the mass. So mass is F over a. So let's take a look. Because the force on m1 is the force on m2, so m1 a1 equals m2 a2. We rearrange this equation, we have m2 over m1 equals a1 over a2. What does this equation tell us? Is that for the same net force, the ratio of the mass of two bodies is the inverse of the ratio of their acceleration. That means the more mass you have, the less acceleration you have. So mass and acceleration are inversely related. Another thing we need to know is when the two objects are fastened together, the same method shows that their composite mass is the sum of their individual masses. That means when the two objects are fastened together, we can treat the two as one object. So we can treat two as one object with the total mass of m1 plus m2. Newton's second law tells us if a net external force acts on an object, the body accelerates. The direction of acceleration is the same as the direction of the net force. The mass of the body times the acceleration of the body equals to the net force. So acceleration is directly proportional to the net force and inversely proportional to the mass. Since the equation is really a vector equation, so we can use it in component form. So that means sum of fx equals max. Same is true for fy and fz. So in this equation, sum of the force means you add all the force together, and that force has to be external force, it's not internal force. Another thing is you need to know ma is not a force. Ma is the sum of the force. The equation is only valid if the mass is constant. Also, the equation is only valid in the inertial frame of reference. That means in the frame of reference that's not accelerating. Let's take a look at this example. Determine acceleration from a force. A worker applies a constant horizontal force with magnitude 20 newtons to a box with a mass of 40 kilograms resting on a level floor with negligible friction. What is the acceleration of the box? So from Newton's second law says acceleration is sum of the force over mass, so we get 0.5 meters per second squared. The direction of acceleration is the same as direction of force. Another example, a waitress shoves a ketchup bottle with mass 0.45 kilograms to the right along a smooth, level launch counter. The bottle leaves her hand moving at 2.8 meters per second, then slows down as it slides because the constant horizontal frictional force exerted on it by the countertop. It slides a distance of 1 meter before coming to rest. What are the magnitude and direction of the friction force acting on the bottle? So let's see, from what's given to us, initial velocity, final velocity, and distance, we can find acceleration using timeless equation. So acceleration is negative 3.92 meters per second squared because it's negative because the object is slowed down. From acceleration, we can find net force Fx equals max. So the force equals negative 1.76 newtons. The magnitude of force is 1.76 newtons. The negative means the force is to the left. Test your understanding. Rank the following situation in order of the magnitude of the object's acceleration from lowest to highest. Are there any cases that have the same magnitude of acceleration? So you are given the mass and the net force. To find acceleration, you use net force divided by mass. You can figure each one of them, and your conclusion should be the lowest one is C, A and D are the same, and largest one is B. That's it for today. Thanks for watching. See you next time.